Hi, welcome to the Machine Ethics Podcast. This is a bonus cast asking the question, what is AI? We hear from former interviewees from the podcast over the last 3 years, Cosima Gretton, Matthew Shannon, Rob Waltham, Michael Ludden, Greg Edwards, Michiano Floridi, Christopher Nozzle, Andy Budd, Damien Williams and Miranda Mulbray. I'd urge you, if you're not a frequent listener to the podcast and you like what you hear in some of these answers, to go seek out the person's interview in full. If you'd like to support us, go to patreon.com/machineethics, and you can find the rest of the podcast and how to contact us at www.machine-ethics.net. What is AI?
I think for me what it conjures up is our own incessant moving of the goalposts. So whenever we create something that achieves what we originally defined as artificial intelligence, we then decide that it's not artificial intelligence anymore. So if you look back in the history of AIs, it's kind of, it's been very undulating in terms of hype, and then complete kind of periods where the AI winter, where people would kind of, give up on the goal. But I think what's interesting throughout that is that whenever we create an algorithm that can achieve a particular thing that we once considered AI, then we decide that after that actually is not necessarily proper artificial intelligence. It's only another form of computation. So I think, that's what I think is quite interesting, is that the definition tends to change and move depending on what the next challenge is. I think the thing that it tends to conjure up for the moment is, the emergence and the proliferation of machine learning techniques, and the success of neural nets that hasn't really, it's an approach that's old, but it's really only been in recent years that we've had the computational power and the amount of data to actually achieve it, because one of the things about neural nets is you need vast amounts of data to train it on. So I think that's
a nightmare at times, I think. And so for me, when I think about it, I think about the regulatory aspects of it. I think, well, we're going to have a lot of that. We're going to have to adapt ourselves. We're going to have to adapt our thinking, our knowledge. We're going to have to, I always think, especially with these sort of areas like drones and driverless cars, you've got to kind of adapt the public perception as well. The public they're quite scary things, these are. So when I think
to me. So first of all, we have to look at what intelligence is, right? Let's just look at that, and then it gets easier. So intelligence is, I would go for a very broad definition, which just says it's about doing the right thing at the right time. Mm-hmm. So a stone doesn't do the right thing at the right time; it just sits there in the sun, right? It doesn't actually move; it's inanimate. But a plant does do the right thing at the right time. It senses its environment, and it puts leaves out at the right time, and it moves its leaves towards where the sun is. That's that simple phototaxis. So it moves itself towards the sun. So I would say that a plant, a tree, would be an intelligent thing in that sense. It has no central nervous system, it has no brain, but it does behave intelligently. So given that very broad thing, then an intelligent agent is simply something that senses its environment. It has some internal objective or plan for how it wants to change the world to its benefit. And it has some ability to interact with the world to affect that change. And then a robot is just a physically embodied. So agents might just exist inside machines, inside computers. They could exist on the internet. They're not physically embodied. But a robot is embodied as well. So it has it physically interacts with the world, arms and legs, sensors, and so on.
Yeah.
Sure. So when we talk about artificial intelligence, it's sort of becoming an umbrella term similar to cloud or big data, right?
Yeah.
Like what do they actually mean? They mean a lot of things, but specifically what I think most actual AI implementations mean right now are using what you mentioned a moment ago, machine learning algorithms. And this could also be considered narrow AI in the sense that if you're familiar with AlphaGo, Google's machine learning algorithm that beat the world's best Go players, or before that, IBM's Deep Blue that beat the world's best chess players. These are systems that use unsupervised learning techniques to, at their core, machine learning algorithms are systems that learn on their own. So you point it in a direction, you say, I need this result, and then it will get there. And you're not always 100% certain how it does.
Yep.
It's a bit of a black box. But that's essentially, I mean, this is a gross oversimplification, but just to kind of get the point across without going too into the weeds.
Is that artificial intelligence isn't one technology. It's really a goal. It's an objective. It's the idea of creating a machine that exhibits some form of intelligence. Now, actually, to define it, you've got to ask, what do you mean by intelligence? And intelligence is a really, really tricky term to pin down.
Sure.
So if you can't define intelligence, you can't really define AI.
But you could define, like you were kind of mentioning, a goal, which might be that I think it is intelligent to do X, and then therefore this AI is intelligent in that way. Maybe could you say that?
Right, but absolutely. So it's like beauty is in the eye of the beholder. It's kind of subjective to what your definition of intelligence is.
Yeah.
So and I think the definition of artificial intelligence changes. The gentleman who actually coined the term, John McCarthy, he coined that back in the 50s. He's actually quoted as saying that as soon as it works, no one calls it AI anymore. As in, the goalpost kind of shifts with the technology. And I think it's really true, because I think if you ask someone what AI was back in the 50s, really what they thought of AI, our smartphones could do now. Probably the power of a handheld calculator can execute some sort of logic in a way that it would have seemed intelligent back then, but now our expectations for intelligence in computers is a lot higher.
And thinking, look, what we're really facing here, it has got nothing to do with intelligence, and it's got everything to do with agency. Is a way of delegating empowering machines to do things instead of us. That they are or are not intelligent, honestly, that is really not the point. Not least because I can check right now, my iPhone in my pocket plays much better chess than anyone I know, and probably anyone around me. And yet, has the intelligence of my grandmother's fridge. So clearly, zero intelligence, amazing abilities. Those abilities will keep growing. There's probably not bound to what we can, at the moment, speculate in terms of, are we going to have a machine that we designed that can do that instead of us, for us? I'm not quite sure. Meaning, I think the sky is the limit. Yes. Are they doing things like us? Of course not. I know
as approaching and then exceeding human capabilities is a very loose definition of what I've got.
Yeah. So approaching human level capabilities in the sense of actions and betraying sensitivity, or what kinds of things are we talking about? You talk about
specifically achieving goals, right? Across a variety of contexts, because we already have lots of little things that can achieve small goals in small contexts. My Roomba can vacuum my floor, but when we're speaking about maximize the number of paper clips that you make AI, it can achieve that goal using a number of different mechanisms, and using the stock market, using whatever actuators or robot it's got controls over. So really, goal pursuit with a broad strategic capability of how do I pursue that goal, and then a strong number of actuators that it can take actions to achieve that goal.
Groovy. So,
dictionary definition. In fact, the term artificial intelligence, a lot of people find very problematic. The term artificial kind of seems to imply that we are trying to create a like-for-like, indistinguishable intelligence that's indistinguishable from humans. And I think that creates a lot of fear, uncertainty and doubt in media. Like, are we going to create these robots that are seemingly human, that we can't tell the difference, that kind of operate in a kind of a human-like way? And I think that might happen, but I think it's many, many years off. A lot of the people that I sort of associate with prefer the term machine intelligence to clearly distinguish the fact that we're really talking about creating something unhuman-like, but that approximates or is similar to the kind of problem-solving, kind of independent problem-solving that humans have. With machine intelligence, the key component there is machine learning, and so how machines learn about the world, learn to make decisions, learn to improve over time. And really, this is what we're at the moment. We're looking at how we can train algorithms to be more accurate at doing often very simple things like spotting the difference between a hot dog and a hamburger, let's say. So it's really using algorithms at scale to solve complex problems where we, as the programmers, don't necessarily know how they have solved that problem, but we've created an algorithm and fed it with training data that will, through a series of kind of, often black box kind of processes, solve those problems. So that's not really a description or definition of artificial intelligence, but I think that's because the concept is slightly more complex and nuanced than just having a one sentence answer. So hopefully that's helpful.
I mean, AI, artificial intelligence, I don't personally like the word artificial in there. I've never liked it, because anything that can behave in a way that we agree is intelligent is just intelligent. It might be a generated intelligence, it might be a created intelligence, it might be a non-biological intelligence, but it's still intelligence. But when I think about an autonomous generated intelligence, and that term I get from a theorist named Emily Dare, autonomous generated intelligence, because we might not intentionally create it. It might accident into existence. But it is something that can generalize, that can take different inputs, that can learn from its past mistakes, that can learn from its past states of experience of existence, that can say, okay, this didn't work, why didn't it? What are the reasons it didn't work? And say, okay, this did work, but only in these scenarios. What are the commonalities between those scenarios? That can learn to engage with different ways of living in the world, different types of minds that it might encounter, different types of humans that it might encounter, animals, non-human animals that it might encounter, and learn from those things and learn to work with those things. In a similar way, maybe it won't be the same kind of way, but a similar way to what we think of as intelligence in other animals.
Great. I don't like using the term because I think it leads to the wrong impression about what's possible. It means that people are automatically using the analogy with human intelligence.
Yeah.
The kind of AI that I've used is machine learning, and I prefer to say machine learning. And that is exactly as you said, adapting that the algorithm is automatically updated as a result of its processing.
Yeah. So as it's going through, it's updating what it produces as an output, given an input, basically.
Yes, and normal code, you give me an output, it's processed by software. Sorry, give me an input, it's processed by software, produces an output. Machine learning, you get an input, it's processed by software, and this produces both an output and an update to the software, or the weights that are in the software. So the algorithm itself has some part that adapts as a result.